Hi there, I'm Marty the OT guy and you're not. Welcome back, it's another episode, this time June. Wow, where is the year going? Let's start off, let's kick this into gear because we've got a lot to cover in a short time to do it. And I'd like to share some news with you about some new things that we're doing at Nozomi Networks that'll all be coming out about the same time as this video. We are going to do a demo of Nozomi Networks' new ARC Endpoint Sensor and how that works. And we've got a lab challenge over here on the bench, something new to wrap your head around. We're also going to share a short war story about the importance of selecting good security solutions and defense in depth. So let's get going. At about the same time as this video is due to release, Nozomi Networks will be releasing CentOS version 23.1 into general availability. There's some pretty cool new features in there. We'll do a special video just about those on their own, but keep an eye out for it. It's worth having a look. On the other side, we have Vantage IQ. We've been talking about this for a while lately. I released a short video about it a couple of weeks back. Vantage IQ is AI-based analytics. You imagine all the information that you're vacuuming up through your Nozomi Networks Guardian, or it's coming up into Vantage. There's all this information there, and maybe you just need an easy way or a smarter way to look at that information and work out what it all means, and that's what Vantage IQ is there for. So keep an eye out for that as well. We've got lots of information coming up. And again, we'll do a special video. Probably the next OT Guy episode will be dedicated to Vantage. But yeah, that's the two big things for this month. Keep an eye out for those and jump on them when you see them. Okay, this time round, let's talk a little war story about CCTV. CCTV, security cameras. So the environment I used to work in, we'd done pretty well with our security perimeter. We had good fences, we had good locks, lighting, electronic security, access control, all those things. What was sort of really missing was CCTV. And we had a few cameras, they kind of worked, but they kind of didn't. And I went about a process of selecting a quality camera provider with a view of installing it across our entire asset base. And we had this one site, which is quite remote, and we installed a single camera, threw it up on a nice high pole. I think it was a 6-meter pole, and we had a dome at the top. And this particular camera manufacturer is actually a really cool model. It's quite a large dome, and it has 3 cameras in it. So this thing had a 270 degree, well, it might have been just over actually, it might have been a shade over 270 degrees of view. So we're able to see the entire site with one camera, which is kind of cool. And it was really good footage too. I think we're talking, 4K footage off this as well. So it was really good. And we installed it, and a lot of people went, you're just wasting money. This isn't helping. There's no need for security cameras at the site. Okay. So anyway, one day there's some guys working on the site, and they're working within close proximity to a high voltage transformer. And unfortunately, that transformer failed. And exploded with a big, an arc flash occurred. Thankfully no one was injured, but I remember the production team coming to me going, that security camera you put up, is there any chance that we could review the footage? So we did that, and we found that sure enough, the camera had fantastic imagery of what had happened. And because we'd taken the time, selected a good camera, a good manufacturer rather, a good vendor, we'd put in a good solution, it was so easy to take that image that we needed, the footage that we needed, to extract it in an encrypted and protected manner, drop it onto a flash drive, follow a good chain of custody, and that information was available when our WorkSafe, our OSHA or our Labour Department, when people were investigating what happened and whether the situation would go any further. And it was at that point where people started to realise that, hang on, these cameras, we got them under the security budget, but they're actually quite useful over here under production as well. So we were able to extend the project dramatically. And for following years, we actually got a significant donation from production towards the security camera project, which was really good. And to me, what it enforced was, if I design my security solutions properly, not only do I get my defense in depth and all the other good things that this added in, but I brought value to the production team. I was able to add value to the production team, and we were then going around installing cameras at various sites, and we might have a camera here that's looking at a gate, and then just, alter the lens, change your viewpoint a little bit, turn it a fraction, and make sure that you can pick up that thing that's really important for production as well. Or once you get the camera infrastructure in, it's only an extra $1,000 or a couple of $1,000, and you throw a camera in looking a different direction. So that's all well and good, but let's just roll back and look at vendors a little bit more, because you need to select a good vendor. If you've been following along some of the reports that have come out of Nozomi Networks Security Research Lab over the last 18 months or so, you'll see that we've found a lot of security issues with a lot of camera vendors. So I really encourage you, do your homework. Do your homework. Take the time to really assess what's going in and the quality of what you're putting in, because the last thing you want to do is install something that maybe meets some of or most of your needs, but actually puts you in a worse position. And the other tie-in here is when you've got your camera system installed, and this is part of the demo we're coming up to now about the ARC system. You can extend your Nozomi Networks Guardian or using the ARC endpoint sensors to protect your camera network as well. You may not have thought of that. You don't really need to monitor the video stream. Okay, it's doing its own thing, and if it's a good camera manufacturer, it's encrypted, and there's nothing really to monitor, but the management traffic may not be encrypted. Or you may be able to monitor for changes in the endpoints, new cameras, things coming online, offline. That's where the Guardian, Guardian can really win. And if those CCTV endpoints are running Windows, maybe they're running Linux, that's where ARC comes in. So let's not talk anymore about war stories. Let's jump across and do a demo on ARC. Let's start with what is the ARC endpoint sensor and why did we do it? So the ARC endpoint sensor, Nozomi Networks ARC endpoint sensor, it's the latest cool toy out of our engineering and product departments, where we're now able to provide deeper insights and better visibility at the endpoint level and detect malicious or compromised endpoints and insider attacks through user actions. We did this to extend the capability of our Nozomi Networks ecosystem, the whole family of tools, right? We're able to bring some of the features of the Guardian sensor down to an endpoint, and then on top of that, add some other features such as Sigma rules and USB monitoring, and get that deeper level of visibility and understanding right down there at the endpoint level within your network. Okay, here we see an ARC architecture diagram. And you can see there's a Guardian sensor here, and that Guardian sensor is communicating with Vantage, upstream with Vantage, and downstream it's got a switch. Off that switch towards the bottom of the screen, just up there a bit, or up there a bit, you can see some remote collectors connected to PLCs and OT devices, and then sort of maybe just up there and a little bit to the right of the screen, you can see some ARC sensors that are connected or they're running on endpoints. Then towards the top of the screen here, you're going to see two ARC sensors that are working with endpoints and connected directly to Vantage. So it's really flexible depending on your environment. But the ARC sensor, as I said before, it extends capabilities that the Guardian has and pushes them down at the endpoint level. So you're seeing things a lot closer to the source. You can see a lot more detail. And it's light touch. It's super light touch. The whole thing is like 100 meg on disk and 80 meg of RAM when it's running. It's nothing. It's teeny tiny compared to what will be running on the workstation under normal conditions. What about some use cases and some deployment scenarios? So how about continuous monitoring of employee mobile devices when they're off the corporate network? You can have ARC sitting there running separate, and when they come back to the corporate network, we can connect and transfer that data. You've got the ability to incorporate air-gapped devices into the Nozomi Networks ecosystem and be able to query and understand what's happening on those endpoints. You've got the deeper intelligence and insight on your critical endpoint devices. You're just going to see that much more It's going to be that much better. Continuous monitoring of endpoints. If that works in your environment, you can run this continually. But remember, like I said earlier, if continuous isn't an option, why not those one-shot runs during maintenance shuts or at times when you can do it? You're going to collect more information that way, and you're going to get a better view of your assets overall. Automated deployment, good Lord. It's actually a really cool deployment system, and when it's properly set up, you can do it. It's automated. It's very neat, and why not across thousands of devices? Why not? It can work. It can be done, and it's very low impact, right? I said earlier, 100 megs on disk, 100 megs in RAM, job done. And it just sits there and runs, and you can do that within an air-gapped environment, fully disconnected if you need to. Gather that information, pull it back later for further analysis. One of the new features in the Nozomi Networks Guardian is the Credentials Manager, and you'll need Credentials Manager to use Arc properly. So let's take a look at Credentials Manager. We start off in Settings, and I'm using the new GUI here. If you're not familiar with it, check out some of our last videos. We've taken a closer look at that. And here in the settings, we have Credentials Manager. So you can see here I built some credentials for devices that exist within my lab. And it's really simple. You just add identity and go, I need an SSH identity. And we're just going to create a demo one here. And we'll put in some Greek for that, and give it an IP address, add, that's it. And if you happen to use common credentials across a wide range, across a subnet or something, you can just enter it that way. You can see how that works here. Hit save, bang, that now exists within our credentials. It's really simple. So the ones that I've created so far are Lab Ubuntu and my two SCADA WinRM and things. Those are the ones we'll demo on today. So if we want to use Arc with our Nozomi Networks Guardian or through Vantage, first thing you've got to have it licensed. Okay, you have to have an Arc license, and once it's licensed, you're going to see the Arc button appear on the navigation bar. So when we click this, it takes me to a page which tells me about all the endpoints in my network which might be suitable to run Arc on. And it's basing that on the operating system information. And you can see there's a lot of info here about the devices. And if I sort by deployed version, you can see I've already put Arc on a couple of devices within my lab here. And really, that's all there is to it. It's pretty simple. You install, you deploy, and we'll demo that shortly. You do the deployment, and then you start pulling information back. So we'll show the deployment, and then we'll come back and take a look at what sort of information we get when we have Arc in the system. So over here on the Lab Ubuntu VM, you can see that I've used the browser and I've connected to my Lab Guardian sensor. The reason I'm doing this is a really easy way to download and deploy Arc. So, as I said before, the lab sensor, it's got Arc installed, it's all licensed, ready to go, and I need to download a version here to this endpoint. So I go into Sensors, and we've got this Download Arc option, right? And if I click here and I select the Linux version that I need, it does the download. And you'll see it come up, there it is. So it's downloading nicely. And I've already downloaded this and unpacked it and all the things, so for demo purposes, we'll just swap out of here. I'll drop into my terminal. So this has been unzipped and copied to an appropriate directory. So using sudo, we just run the Arc executable. Now, here, okay, so there we go. Arc is now running as a service, right? Very, very simple. It's sitting there running. It's running continuously. There's a stop button there if I needed it. This is what we see from Arc. Configuration-wise, we have to tell it where we're connecting to. So we've got to tell it the endpoint that it's connecting to and give it the synchronization token. Check connection there. Upstream parameters are correct. Hey, it's working. It's really quite simple. A couple of other things we want to tell it to do. Very, very easy. So this information's here. So what happens now back on the Guardian sensor? Let's see what we get. So I switch back to Guardian, and this is the page that we had open previously. So we'll close that out and come back in again and see what sort of information we've got. It's different now. Okay, we're now seeing something very different. I've got vulnerabilities we've picked up. It's telling me that the source is Arc. So we've now got the operating system is correctly identified as Ubuntu Linux 2204. Okay, we're still passive detection on the vendor. That's fine. Passive detection on these on the MAC address, but Lab Ubuntu's come up with an Arc detection now. So we're starting to flesh out. We're starting to see more and more information from our endpoint. So this time we're now looking at a Windows endpoint. And again, I'm connected to the Guardian sensor, and I'm on the sensors page, and you can see that downstream, we have two sensors connected on Arc. So you can see the Lab Ubuntu sensor, which on 5213, that's what we're doing. And you can see my PC on 5254, which is a gateway out of the lab. So this PC is actually on a different subnet. But the point is, it's still working. And it's running fine. So on my PC here, let's take a look at how the Arc configuration is set up. So swap over to that tab. When you run Arc, depending on the platform you're running on, you get a slightly different status page. So we saw the Ubuntu one earlier. This is the Windows one. So you can see here there's some required dependencies. And this is part of the install of Arc. And you do have to plan this a little bit carefully as you go along. You need to have sysmon in there. You need the PowerShell script block logging, you need USB PCAP, you need WinPCAP. Those things have to be there for Arc to do its job. You can see I've got it running here, running as a service. It's a wonderful thing. Go back to the sensor and let's take a look. And this time I want 20.2. Okay. So this is the details for my PC. So now we can see the operating system has come through with the source of Arc. We have Arc is telling us that it's an ASUS system, and sure enough, it is an ASUS system. Still a passive detection on the Mac. Not worried about that. Arc for the host name. Arc for the system product name. The type computer from Arc now, and serial numbers come from Arc. So because Arc is it's a more reliable source than passive detection. It's querying the actual hardware and the operating system itself. So the information has a higher priority than the passive info did, and it will replace that within the database. But you can see here, there's 151 software pieces installed on my PC. That's mostly games. Don't tell anyone. You can see whether I have missing hotfixes. You can see that I have hotfixes installed. You can still see there's some alerts and things that are going on because this node is still not learned, and that's part of this demonstration. I deleted it out of the Guardian so that we could do this properly. There's all kinds of information coming back, and this is really starting to be a well-populated asset entry. If I close this page, shoot across to Arc, I can look at node points. So we've looked at this deployment. Actually, let's take a look at this really quickly. Hey, look, Ubuntu 2204 version 1.1 installed. So that's the that wasn't there earlier in the demo and in the video, right? So now we can see that the Ubuntu Linux has been added. If I jump over here to node points, I can pick on the 3 node points that we've got this installed on. So 213, yep, that was our Linux. And we can see the kind of information that we're pulling back. So there's quite a bit there. There's a lot there, right? A lot of information coming back. Let's check out the Windows machine. Windows machine, antivirus. It's telling me I'm running Defender. That's true. That's what I've got on there. There's plenty of information here. Lots more than you'll pick up passively. So yeah, that's the simple demo for Arc in a nutshell. We can also run it on Mac OS. I'm not demonstrating that today. It's just not quite set up right for that. But yeah, Linux, Windows, this is the bomb. This is you need Arc in your life. You really need Arc in your life, especially if you want to have highly accurate asset inventory information. Check it out. Okay, last part of the demo. Better not forget this bit. This bit is kind of cool. You can see here, I'm looking at the Guardian again. I've got my alerts filtered by .20.2, which was my PC. What I'm going to do is stick a USB drive into this computer. So this is the USB flash drive that Sans gave me when I did my 515, ICS 515 course. So let's bang that in the hole. Go. Bang that in. Windows has said, oh, there's a USB drive. So it's ticking along. It'll pop up eventually. There it goes. There's the content in the USB drive. Just watch over here. Hey, look at that. Look at that. Alert, connected USB drive. A USB device has been connected to .20.2. This is most likely a human-driven event. That's fair. That's a fair assessment. This is kind of cool because we can take action on this alert, right? We can go, hey, why is someone inserting a USB drive on an endpoint that maybe shouldn't have a USB drive added to it? So this is something that you get through ARC. This is cool. If you're working in an environment where, maybe it's not practical to put physical locks into the USB ports, maybe people do need to use USB devices from time to time. Maybe you don't have another software alternative for locking out or controlling USB use, right? This is an option that's available to you. I think this is pretty. Pretty impressive myself. Very cool. Right, so here we are in the lab. Now, before we get started on this month's challenge and a little bit of learning, a couple of people have asked me over the last few months, at the time we've been doing these lab challenges, why? What's it all for? What's the purpose? So the idea is to start with simple concepts and principles that apply to either OT engineering or OT cybersecurity and move towards more complicated things, such as I'd like to see us carry on through this path and end up with some hardware hacking. Grab some smart devices, see what we can get out of them, do little bits and pieces like that. So that's kind of where we're going in the longer term. And each challenge that I create is intended to be a step closer towards that. So hopefully that makes some sense. So this month's challenge is brought to you by a little tiny wee circuit that if it didn't exist, you wouldn't be watching me. Probably most of the IT industry and telecommunications industries wouldn't exist. It's quite a handy little thing. And the circuit or the component in question that I'm talking about is called a phase locked loop, or a PLL. You may or may not have heard of one, but any device that needs to lock to a given frequency and maintain that lock generally uses a PLL. It's one of the easiest ways to do it. And what we're going to look at on the bench today is not a PLL, but it's a component of a phase locked loop, which has its origins earlier than the phase lock loop and has some slightly different uses in industry and things like that. So let's talk a little bit about this phase lock loop idea. So a phase lock loop, you feed it a reference frequency, it detects an incoming signal, the two lock together, and it uses a closed loop, bit of closed loop intelligence to stay on frequency. So without that, you've got no network switches, no routers, timing and clock circuits for computers and other devices suddenly get a whole bunch harder to do. Satellites, microwaves, all of these things, even the camera that I'm recording this on is going to have a phase lock loop in there somewhere to make sure that the CCD operates properly and I get the correct number of frames per second, right? So it's kind of a cool piece of, it's a cool little circuit, and if you could mess with it, you could have some really interesting results. Another use for a phase lock loop, which takes us right back to the operational technology side, is along the lines of generator synchronization. So if you're familiar with the Aurora experiment, which was done in the States, the videos are all over YouTube, and you can see this lovely green diesel generator and they mess around with the synchronization and it fails mechanically. If you can mess with the synchronization of a generator, you can get some physical results. That's what that video proves. So a phase lock loop can be used to detect the grid frequency and then output an error, a difference between the generator frequency and the grid, and then bring the two together, and when they synchronize, it's good to go. That's what a phase lock loop does. Right. So on the bench here, I've got a component of a phase lock loop. I'm not building the whole thing from scratch. It's a nightmare. You can buy an IC that does that, right? There's no point in me messing around with it. But what I've done is I've built a component of it, a small part, to give you an idea of how some of this works. And this piece that I've built used to appear quite a lot in industrial instrumentation, where you would take an input and you'd get this kind of output, and you would use that to control processes. And it would often be done in a discrete unit that might mount on DIN rail, something completely separate from a PLC, might not even be integrated into a control system as we think of it today in OT. So it's a totally separate part. And I've got two questions for you, and we'll go through those as we tick along. So while we're looking down at the bench, I'm going to focus in on what's happening here. So you won't see me, you'll hear me, but you won't see me, except for the arms coming in and out of picture to make adjustments and demonstrate the circuit. Let's take a look. Okay, so here we are looking down at the bench. So the circuit's here, built on the breadboard. I've got a reference voltage coming out of my lab power supply, and we've got some traces happening on the oscilloscope. This whole circuit is actually being run off these two 9-volt batteries, because my cheap lab power supply doesn't quite do what I need it to for this, so I had to bungle something together. Now, you can see here that there's two traces. There's a yellow trace, there's a red trace. So the yellow trace is outputting a sawtooth wave. That's cool, nothing unusual about that. And the red trace is just sitting on a line. But if I start to mess with the output voltage on the power supply here, and we start to creep that up, see what happens? Isn't that interesting? So as I play with this voltage, I get a change in my output waveform. And that's one of the questions for today, for this challenge, is what is that function or that circuit called? There is a specific name for it. It comes down sort of like PLL, phase lock loop. It has a 3-letter acronym, and it describes what this circuit does. And this component, this part of it, feeds into a PLL, into a phase lock loop to achieve, well, to make the PLL work, right? So that's what we're doing here. As I mess around with this voltage, I get a change in my waveform. Really super simple. So the first question is, what is it? What is this function? The second question is, I could have done this a whole lot easier because there are single integrated circuits out there that do this function. So the second question is, I want you to do a Google and find a part number for a component that would replace all of this breadboarding. For a single IC that would replace all of this, and would have made my life easier. So it's really simple. Two questions. One, what is it? And two, what kind of IC or what maker's number, part number, would be the IC that would replicate or replace this circuit? Dead easy. Go for it. Okay, that brings us to the end. I hope you found all of that useful. I look forward to seeing your answers on the lab challenge, or feedback on anything else. If you've got any questions, get a hold of us, give us a shout. We're more than happy to help out. Message me below, drop a comment. I'd love to hear from you. Until next time, see ya. Bye.